Hey guys, who's
Hey
in the stream right now?
everyone.
All right, don't be shy. We've got 19 live. Y'all can
Got
participate.
25 people. Hello everyone.
This is pretty normal for. All right, we got a hi. Hey.
Hi.
Hey. All right, awesome,
Yay.
cool. Um, so this whole stream is going to be part of our big cram session thing pre-AP exams. Basically, you guys ask a question and we'll answer it. And if you guys don't have any questions, we'll go through some FRQs for you guys. So we can get right to it.
All right. Here's the weekly stream calendar in case you guys also have any other APs. Here's the schedule for when the streams will be happening. I'll probably be attending a few myself. And yes, you should definitely follow Fiveable on all of your social media to get updates on when there we go, there are the big slides on when streams are live and how you can get access to more content.
Okay, cool. I don't even know it did that. Wow, that's fast. Okay, so there's an ask a question tab right below the slides right there. You can put it there, or you can just ask straight up in chat. You should probably introduce yourself though. My name is Jacob. You can't see my face because I don't have access to a webcam right now. The only computers in the house that have access to webcams miraculously don't work because no one else in this family takes care of the computers except for me. So, so you can if you really want to see what I look like, I have an Instagram, and you can just look up JJeffries12. And we got our first question. Okay. Can we go over differential equations and slope fields? Sure.
Of course.
So I'm gonna open up this program here, and I'm gonna draw out some stuff. So I have to change the tab that I'm streaming. So hold on. Oh, I forgot Crowdcast sucks, and we can't do that. Okay, so I think we don't have a slope field question on the slides. So how are we gonna do this?
That would be unit 7. And let me check if we have. Yes. And
Can you open up your can you share your own thing? Because I'm like scared if I close this video, it's gonna shut the stream off.
Okay.
So you just like open up like MS Paint or something and draw with your mouse.
All right, let me. All right, is everyone good with my screen?
Yeah.
Okay.
So, Kalia, or I hope I pronounced that right. If you have any specific questions about differential equations and slope fields, that'd be fantastic. Because we're gonna be going over that in the full cram session next week, and I don't want to take up a lot of the screen time with just one single big over branch topic. I'm gonna close video. Okay, yeah, actually, so
Initial value problems.
close video.
Okay.
Why can't I share something else? All right, that's fine. Oh wait, hold on. I can actually open this up. I forgot it working. Okay, cool. So, Lean, they can see the the paint on that window I have open right now.
So is that your screen?
Yeah, can you see me drawing?
Yes. Okay. So just to answer a few, just to like clarify, I'm gonna talk about the slope fields for a second, and then we can go into the initial value problems. So mainly what AP Calculus will ask you to do if you're given a slope problem, what they've done in the past is ask you to sketch the slope field such that dy dx equals a given equation, and then it gives you intervals for both x and y. However, I do believe that this year's exam, they will not be requiring you to draw anything. Therefore, I don't believe that you're going to be expected to actually draw and fill out a slope field. But I do think that there is a possibility where they will ask you to match a slope field with a given equation. And to do that, you kind of have to have an idea of what the parent function looks like.
Got it. I got the calculator
Okay.
question. Keep on going.
All right, cool. You can get that. And then after you figure out what the parent function looks like, you're really going to be looking at the dashes in the slope field to make sure that the line that you would be drawing on the slope field, which you can use with like scratch paper or anything, to make sure that it's going to follow the exact slope of the line that you would draw when you are drawing the given equation.
I can go an example, like actually drawing it out on this software right here, if you want me to.
Yeah.
Okay, cool. So focus screen. So basically what the kind of idea of a slope field is, you have some differential equation, dy dx is some function of x and y. So that could be something like y prime, I'm using interchangeable notation here, is y plus x. You can't explicitly solve this using separation of variables. So one thing they could do is say which slope field fits this differential equation. And one way to do that is to draw just an xy plane, right? And take multiple points. So we'll do x, y, and then y prime at those values. And we'll do -1, 0, 1. Hold on. -1, 0, 1, -1, 0, 1. So say we have 1 here, -1, 1, -1. This is the y-axis. This is the x-axis. So I did not include a lot of points here just for the sake of time, but what you can do is you could plug these two values directly into the differential equation that you have right here. So at -1, -1, y prime equals -2 because you just add x and y. So the point here is at this point, the slope is -2, and you can sort of draw a straight line with that slope. And at 0, 0, the slope is 0, so it would look like, I'm going to draw some blue actually. So you have -2 here, you have 0 here, and then at 1, 1, you have a positive slope of 1, or you have a positive slope of 2. So it looks sort of like this. So one thing that you can do is with more points, you can sort of sketch, you can sort of just like sketch through the slope field. So I want to make just an arbitrary slope field with no real matching equation to it. So I don't know, it looks like that, and then like that, and I don't know, just some random lines. So like, let's say the initial condition said, f of -1 is like 2. So that means that this point on the slope field is right here. So the curve growing through there would look something like this. It would be following that original slope there. So when you see this big slope field, which I'm going to find one real quick online so I don't have to draw crazy stuff out. So I have right here. So what you can think of is this slope field is like sort of like a fluid flowing. Like this kind of looks like a vortex. And if you have any initial point, let's say it says 1, 2, 1 is an initial point. What the solution curve would look like is it would look sort of like that, like it'd follow the slope field. like that. So, and then let's say it gave you the solution of, let's say 4 was an initial point for the differential equation. It would look something like that, and it would just keep on going around. It would follow the flow of as if it were a vortex. Since we could use calculators, well, we have to show work for any definite integrals. That's a great question. The problem is that it will very explicitly tell you if you have to show work. But I'm assuming because they're really good with making sure that like everything that's on the calculator or everything that's on the calculator section, all you need is a calculator and some knowledge. You don't have to do any work to show it really. So I'm assuming probably not. But at the same time, it's probably a good
Yeah.
idea to do that anyways for extra points.
I don't think that you need to necessarily have the work written out for like, like every step shown of like when you're plugging in the definite integral. However, it's normally the scoring guide does include points for having the original integral set up and then having the next step set up where the antiderivative of each of the values. So I think as long as you have those actually plugging in the values for x, I don't think you have to show it. So I think you just have to make sure that you get the points for showing what exactly you're doing and showing that you know how to do the antiderivative, since that's the majority of the exam. One of the questions was about Simpsons rule. Simpsons rule is actually not on the AP exam, so that's great.
And because of that, I literally forgot it. So we're going to go to the next question about initial value problems. So basically, I'm going to just shortly define an initial value problem here. So an initial value problem here is you have some differential equation. We'll just call this g for any function of x and y, and then you have y of a equals b. And they give you this condition so you could solve for a general thing. So let's say you have the differential equation y prime equals y. You solve this by separation of variables. You rewrite the y prime as dy dx equals y. Get all the y's on one side and all the x's on one side. You integrate, and then you have natural log of the absolute value of y is equal to x plus some constant. There is a constant over here, so I'll be a little more explicit about that. So let's say these don't have to be the same constant, right? So you could write this as c sub y is equal to x plus c sub x. Both of these c's are constants, but when you subtract this over onto this side, ln y is equal to x plus c sub x minus c sub y, this term is still a constant, right? So you could just write this entire thing as c. So you have ln y is equal to x plus c, and then you could take the exponential on both sides. You get absolute value y is equal to e to the x plus c, but by exponential properties, that's also e to the x, e to the c. But this is also just a constant, so we can call it k or something. And then there's an absolute value here, and the way to kind of undo an absolute value is to just stack on a plus or minus. So you have y equals plus or minus k times e to the x. And this will work, like this satisfies the differential equation up here. But the problem is this is general solution. So this is a family of curves, right? Because of the k here. So what this would look like on a graph is for k equals some number, it would look like this, and then sometimes it would look like that, and it would look like that. So with an initial value problem, instead of having this family of curves as a solution right here, you have one single curve. So let's just say y of 0 equals 1. This allows you to solve for k. So you have y of 0 equals plus or minus k e to the 0. But e to the 0 is just 1, so this comes out to plus or minus k. But y of 0 right here was already 1 to begin with. So you have k is equal to plus or minus 1. And there's, of course, that's we've boiled it down to two curves now, right? So when we boil it down to two curves, we have y equals plus or minus e to the x. And then we can plug in this initial condition again to see if what we have makes sense at all. So let's put y of 0 is equal to plus or minus 1 because e to the 0 is 1, but this is equal to 1, right? Because y of 0 is also equal to 1. So this negative term, or this negative solution rather, is no longer a thing. So now we have this specific curve being y equals e to the x. So that's kind of the point with initial value problems, is when you solve a differential equation, you're always going to get at least one constant. And in terms of AB and BC context, you're always only going to get one constant. So the point here is that when you solve the differential equation without an initial value, it becomes a family of curves, not just one curve. But that initial condition that they give you for the initial value problems boils it down to one curve, and it's your job to find that one curve just by plugging in the initial condition and solving for that constant.
All right. I'm gonna just answer a few of the questions in the chat. So, the trapezoidal rule versus the midpoint rule. I would recommend using midpoint rule because that tends to be more accurate, and more often than not, they're going to give you like a chart of values, and that's why it's more convenient to use the midpoint rule. But it's also more accurate because if you calculate the error bound, which calculating the Lagrange error bound is not on the exam this year, calculating the error bound in most cases results in the midpoint rule being more accurate. However, there are some like very unique cases where trapezoidal is more accurate, but I think that if it just asks you to approximate, whether or not it's more accurate isn't going to really impact the amount of points you get on that, because AP readers will know to look out for more than one way to approximate. But I think that the easiest way, what was I saying? The easiest way is to look at the points, and I think it's to use the midpoint rule to create rectangles like that. And also, like, the formula for a rectangle is just generally more easier. It's just base times height, whereas trapezoidal, you'd have to go into quite a bit more arithmetic.
Yep. So I'm adding on to her point there. You can see that you have all these, like with trapezoidal rule, you have all these wonky shapes. The pink is trapezoidal, by the way. I'll just put TRPZ. So of course this isn't completely right, just because I'm drawing it, and those trapezoidal endpoints aren't completely right, but these aren't arrows, these are individual shapes, so like they kind of share that boundary right there. Let's see, that a little better. So this is kind of a janky drawing, but trapezoidal, you have to calculate the area of those rectangles right there, and those. For midpoint, you have to calculate the area of those rectangles. For trapezoidal, you have to calculate the area of those trapezoids. And when you're talking about a trapezoid that looks like this, calculating the area, you have to split it up into two shapes, unless you remember the trapezoidal rule, or the formula for the area of a trapezoid, which I think is not something worth memorizing. Calculating the area to approximate that integral, you have to calculate this area. Well, actually, sorry if you're colorblind. That area and this area. But when you have to calculate the area of this rectangle, you just have to do base times height. Whereas this is base times height plus this area, this leftover triangle. Either that, or you memorize the formula for the area of a trapezoid.
And
And
half times height times the sum of the bases.
yeah, I don't like memorizing that. So yeah. Oh, I should close my final grade. That's not something I should have. Well, whatever. Never mind. Okay. So yeah.
Any other questions or topics that you guys want to into? If not, then we can go ahead and get into the FRQs.
We got how much work will we need to show since we have our calculator for the whole AP?
Okay, so there's going to be a lot of justification and this exam, and it's going to be sometimes using your words to justify like why something is the way it is. And when you get problems like that, making sure that you show enough justification, not to the point where it like makes sense in your head, but to make sure that the reader understands and can see the line of reasoning with your justification. But when you're just showing like simple math, you're not going to have to show out simple arithmetic steps using like algebra, since you're going to have your calculator for that. But you're always, always, always going to have to show like the integral that you're using and write out any like formula that you're going to be using a problem.
Yeah, I'm gonna pull up something as an example of that. So let's say you had a function. Say this is y equals 3e to the 2x. And you also, let's just keep it simple. Let's just keep it at a boundary, and you want to find the area from, I don't know, 5 to 0 maybe. For the calculator, minimum work you should be showing is just area equals the integral from 0 to 5 of 3e to the 2x dx, and then your
Antiderivative.
well, but like these calculators can calculate
Oh yes,
decimals.
they can.
Yeah.
Definite integrals.
Yeah. So your answer goes here. This is the minimum amount of work you should be showing. Normally, you get points for the bounds. You get points for the integrand being right, and then oftentimes you will be taking points off if you forget this thing right here, the dx. So that's the minimum
Yeah,
work you should
please
be showing.
remember your dx's and plus c's.
Even more so, you really kind of don't even have to show this thing right here, the area equals, as long as you make it very clear that this right here, this answer you get right here is an area. And some calculators will actually do that in an exact form instead of with a decimal. Mine does that because I'm cool like that. But if it's a calculator question, you're not going to be docked with a decimal, especially if it's just asking you for the straight up area and nothing else.
And yes, when you're using your calculator, it's always safe to round to 3 decimal places. It'll ask you to do that most of the time. And rounding is not like they're going to take the under and the above value for that. So you
Yeah.
can either cut it off after 3 values or round it up.
Yeah. Cutting it off is formally called truncating. You'll see truncate in some of the scoring guidelines. So truncating or rounding is good. So if you have like one of your answers is 2.467, both 2.463 and 2.44 will be acceptable a lot of the times. This just comes from I've used so many colors already. Okay, this just comes from the 7 not being there, and then this comes from 3 being rounded up from the 7. So either one is acceptable in most cases, unless they explicitly say round. I'm even imagine if they explicitly say round, they're going to be fine with you having that 0.001 error, but just to be safe, because they could just one year decide to be strict on the rounding.
And since you're able to use your calculator this year, if you're going to be using one of your calculated values in another problem, I recommend either rounding more places or just like copy and pasting from your calculator so that it automatically plugs into the problem so you get a bit of a more accurate answer.
Yeah.
All right. Any other questions? FRQs.
Cool. So I'll put that on. I have to end this video. Share Chrome tab. Okay.
We're going to be going through numbers 4, 5, and 6 of the FRQs from last year's AP Calculus AB exam. So, but if you guys have any other questions along the way, we can definitely answer those. we'll just be going through these to cover some units.
Yeah, and if your question is answerable with like a sentence, we'll have whoever's not talking answer you. And if you have a question that requires us to like pull up like the blank canvas like I was doing and work it out to demonstrate stuff, just wait out until the end of the stream and we'll spend a few extra minutes on you.
All right, let's do it. FRQs. All right,
So
this next one covers units like 4, 7-ish. I know that you guys were asking about differential equations and whatnot. So this is going to talk about separation of variables, constant of integration, and related rates. So let's get into it.
okay, so this question gives you a cylinder with rainwater. It has a diameter of 2 feet, and the water drains out through a value at the bottom of the barrel. The rate of change of height h of the water in the barrel with respect to time is modeled by the following differential equation. H is measured in feet, t is measured in seconds. So the first one says find the rate of change of volume in the barrel with respect to time when the height of the water is 4 feet, indicate units of measure. So basically, you have the volume relation there, right? The volume relation is v equals pi r squared h. And if you don't remember that, it gave it to you in the problem, which is great. So when you differentiate both sides with respect to time, that pi there is a constant. That radius is also a constant because it has a constant diameter of 2. So the only variable in there that changes with time is the height. So when you differentiate the volume with respect to time, you also differentiate the height with respect to time. A lot of the problems with related rates, they usually have a power on that height. And in this case, it doesn't. So you don't have to worry about any chain rule. So you also have the expression for dH dt given in the problem, and you could plug that right into dV dt with the expression you got. So you have dV dt is pi r squared times dH dt, but dH dt is also negative square root of height over 10, and you can plug that right in, and then you get an expression for the volume as a function, or you get an expression for the rate of change of the volume with respect to time. And Ash, I think Lean cut out. Yeah, it says there's a connection issue. So, yeah, I'll answer you. Do you think the FRQs this year will be similar to the ones in the past? I think they will, but again, I don't know. I'm not a writer for this exam. But again, preparing for this using past FRQs is a great way. So, it'd be more conceptual, must go to the same units. Okay, so she did answer. Yeah, she just disconnected from the stream. I think her Wi-Fi messed up. But to keep on going through this FRQ, dVdt is pi r squared divided by 10 square root of h, and the negative of that. You can plug all these values in, right? So it asks you when the height is 4 feet. So you have pi stays the same. The radius is the diameter divided by 2, and you already have the diameter, which is 2. So you have 2 divided by 2 squared because the radius is squared. And then you have negative 1/10, that stays the same. And then you have square root of h, and the h is the variable you're plugging in. So at that case, or in this question specifically, the height is 4. So you plug in 4 into h and you get an expression for dVdt. Or not an expression, but an answer, and that's negative pi over 5. And there's an issue with the units, right? So what units do you have for dVdt? Well, it's a volume changing with respect to time. And the units in the derivative kind of give it to you, right? You have dVdt, derivative is a ratio. So you have dV, the units on V are feet cubed. That's a volume and it gives you feet in the problem. And then dt is a time unit and it gives you seconds as well. So you have feet cubed per second. So that's part A. And then part B. So it says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. So there's a big problem with these kind of questions. They really catch you with the wording. So when I see this problem, welcome
Hey,
back.
can you guys hear me?
So, oh, we have 3 questions now. Oh wait, no, those are the same questions. Never mind. Can we review optimization? Yeah, we'll go over optimization at the end of the stream. So stay tuned. It's just we
After
can go
this
through it.
FRQ, we can look at optimization.
Okay. So we have I was talking about the wording here with the is the rate of change increasing or decreasing. So
Uh,
when it says is the rate of change increasing or decreasing, you have to look at the rate of change of the rate of change. And that's the second derivative because that's the derivative of the first derivative. So you have to actually get a good second expression for your second derivative. So what's happening here is you have dHdt is equal to negative 1/10 times the square root of h. That's given in the problem. So when you differentiate both sides with respect to time, that second or that left-hand side becomes dh or d squared h dt squared. And you take the derivative like you normally would with that h. So that square root of h is h to the 1/2. And you do normal power rule derivatives with that. You bring down the 1/2 and then you subtract 1/2 minus 1. And then you get you get 1/2 times h to the negative 1/2. And that square root can go down to the bottom. So you have that expression for the second derivative. Why didn't I derivate r? Okay, so this is because r is a constant in this problem. So it says that a cylindrical barrel with a diameter of 2 feet. So it says diameter of 2 feet, which means it's essentially a number, right? So what the scoring guidelines actually do is they don't actually worry about r in any of the calculations at all. They immediately plug r into the volume formula and they immediately say v equals pi h, which is just as valid. So essentially, according to the diagram, that cylinder stays having a radius of 1 feet. So you could actually do product rule here, but you'll find that you have a dr dt term, and dr dt is 0 since r is a constant, so that entire second part of it goes away. So I'm going to ignore any constants here and just say v equals rh in chat. So you'll have v prime is equal to r prime h plus hr prime. Or my bad, not hr prime, it's r prime h plus rh prime. There we go. So that r prime h term goes away if you have v equals rh. So because r is a constant, so r prime is 0 because the derivative of a constant is 0. Does that make sense? All right. Let me know if it's confusing. I'm going to keep on going through the FRQ. So you have the second derivative of h in terms of h and the derivative of h, which is great, except you have to have everything in terms of just h. But you have dh dt is equal to negative 1/10 square root h. And you get some nice cancellations here. You actually get second derivative of h with respect to t is a constant. It's 1/200, and that's greater than 0. So because that is greater than 0, the rate of change of the water is increasing at h equals 3. One thing about the question here is they trick you because what happens is, or at least what happened with a lot of the people that I know that took this, because I took this exam last year with this when this set of FRQs was a thing. A lot of people got really like tripped up that there was no h in the final equation because they thought there had to be because it asked you to plug in. But you see that the second derivative of h with respect to time is a constant. It's the same number for all t. It's greater than 0 for all t, so it's increasing. And the next part of the question says, at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So this is a classic separation of variables question. So the trick here is to see the differential equation, multiply stuff by dt, and then move all the h's on one side and move all the t's on the other side. So you have that square root of h, you divide both sides by square root of h, and you get 1 over square root of h dh is equal to negative 1/10 dt, just by multiplying the dt to the other side. So essentially you're switching the places of the dt and the square root of h. One quick note here is you can actually keep the constant on either side, keep the negative 1/10 on either side, and the problem will still work out the same way. So I skipped some steps here with the integration, but essentially you have 1 over square root of h dh is equal to negative 1/10 dt. So the left side you can write as h to the negative 1/2. And what you do there is you add 1 to the power and divide by that new power. So you have h to the 1/2 divided by 1/2, which is simply written 2 equals 2 times the square root of h. And you're integrating a constant with respect to time. So that just becomes negative 1/10 times t plus an arbitrary constant here. And this is where the initial value problem of the FRQ comes in, right? So you have h of 0 equals 5. That was given to you. It says that t equals 0 seconds, the height of the water is 5 feet. So you can actually plug this information in the differential equation and get a value for c. So when you plug in h of 0 equals 5, that is immediately plugged in to the expression we have above. You don't need to isolate h before you do that. So you have 2 times the square root of 5 is equal to 0 over 10, the negative of that plus c. But that ends up just being 0. You solve for c, and you get c equals 2 root 5. So you plug that back in the differential equation as c, and then you solve for h, and you get h equals that expression. And that's the entire FRQ.
Right. I'm gonna just talk a little bit about optimization. Oh no, just kidding. I'm gonna talk about the scoring guide, then I'm gonna talk about optimization.
Yeah.
So the first part, it had 2 points to, and units. Okay, units is very important when it comes to where they actually give you the units. I know that for most of the problems, they just end up like giving you a graph and you're doing integrals and stuff, and there isn't necessarily a unit. But with something like this, to using the correct units and stuff like that, like similar to physics. And the first point was simply just getting the derivative correct of the volume equation. And so as long as you don't even have to show all of your work, as you have right and you simply understood to take the derivative of the volume equation and then you got the correct units, that's 2 points. B, it's the first derivative is 1 point, then the second derivative as a second point, and then obviously, like I was mentioning earlier, there's sometimes they ask you to explain. So yeah, so you take both derivatives, making sure that your explanation is elaborate and straightforward is very important in order to get that third point on the FRQ. For part C, as you can see, a lot of the points go to part C, and that sometimes happens. And in some cases, if you don't do one step, then you're not going to be able to get any points. So for this one, if you didn't do separation of variables, there's just no way you would have been given credit for the rest of your work. And if you did the first 2 parts, but you didn't end up using constant of integration, the maximum point you can get is 2 out of 4. So it's very necessary that you understand to separate the variables, calculate the antiderivative, and then use constant of the integration with the initial condition to find h of t. And so as you can see, the actual final answer normally takes up only 1 point on the FRQ for like each of the parts. So it's very important that you get the beginning right as well as the end. They're both equally important. I'm gonna talk about optimization real quick for the person who asked.
Okay, I'm gonna.
I think Wait, what?
I'm gonna pull out a canvas again, just in case feel like I need to draw something you're talking about.
Okay, cool. So I personally think it's kind of unlikely that they'll have an optimization problem on the AP exam this year, just because it's difficult to incorporate it with other concepts. And since there are only going to be 2 free response, they're kind of going to make sure that they get one type of problem that you can cover several units within. And with optimization, it's just kind of difficult to do that because it's mainly using like the first derivative test, and then you can't really do anything after that. But in case it does show up randomly on one of the FRQs, you're normally going to be given 2 cases. One of them is going to be what you're going to match, is what you're going to use as the constraint. So reading the problem carefully and figuring out which equation exactly you want to maximize is pretty important. And then when it gives you the next condition, that will be your constraint. And then for your constraint, you're going to solve for one of the values. And for example, it says find 2 positive integers whose sum is 60. P, so that's x plus y equals 60. And then whose product of one times the square of the other is a maximum. So the maximum is going to be xy squared. And so the constraint is x plus y equals 60, and you're going to solve for either y or x. In that case, solving for x will get you 60 minus y. and then you plug in to the next equation. So you're using substitution system of equations. And that will get you to p equals 60y squared minus y cubed. Yep. And then you will be taking the first derivative of that equation, which will get like p prime equals 120y minus 3y squared. And you're going to be setting that up equal to 0 to find your values for y. And when you end up doing that, you're going to get y equals 0 or 40. And then just like you would do on a regular equation when it asks you to find the maximum or minimum, you're going to set that up on a number line and then test both of the points to see where exactly the minimum or maximum is going to be. And in this case, 0 is not considered a negative or a positive, so you can't really use it in this case, but you're going to test out 40. And since there is a maximum at y equals 40, on the closed interval, it is an absolute maximum. And so y equals 40. You're just going to plug that into whichever equation. You're going to plug that into your constraint and find that x equals 20. And that's the process.
One thing I do want to note with this like sum of integer problems and the product of integers is that you can immediately rule out y equals 0 as one of the maxima, because if y were equal to 0, that entire product would be 0, just because it's xy squared. So it wouldn't make sense for the maximum product to be 0 of something.
All right. You guys ready for the next FRQ?
All right. So, wow, Crowdcast is really annoying with this switching applications thing. Okay.
Thanks for doing that, Jacob.
Yeah, you got it. Okay, so next overview. Go.
Yes. Okay. So Unit 8, I'm sorry. I'm going to just geek out of it. Unit 8 is by far my favorite unit of calculus. I'm sorry. My class used like Play-Doh to mess around with how you can calculate volumes using different cross sections and whatnot. I just think it's really fun. And I've seen like a lot of FRQs on the AP exam that are use a lot of concepts from Unit 8 because you can literally come up with so many free response questions that applied to Unit 8 and that just use several other units concepts. I love it. So this is the one where it talks about you're going to be given two equations, or sometimes one equation, and you're going to find the area between curves, and sometimes it'll be expressed by y or by x, and sometimes they're just going to make it so that the dividing line is the y-axis or x-axis, or sometimes it'll make them intersect at 2 points and you find the area between them. You are also in this unit going to be calculating volumes using one of three methods, and one of them is cross section. So it's going to be the difference between those two functions is going to be like one of the legs of a triangle, or it's going to be part of a semicircle or rectangle or square, and you're going to be using those area equations to figure out how to calculate the volume, or you're going to be using disks or washers to calculate the volume. And then the very last like section of unit 8 is arc length, and that's normally applied to like total distance traveled.
Okay, so this question gives you a region, and it says let R be the region enclosed by the graphs g of x equals some cosine curve, and h of x equals some polynomial curve. The y-axis, the vertical line x equals 2, as shown in the figure above. So the first step here is you need to identify which curve is which, right? So one thing that I think is nice for me to imagine is think of the range of that g of x curve, right? So the range there is -3 to 1. And the reason why is because cosine only ranges from -1 to 1 no matter what's inside cosine. So if you plug -1 in there, like not -3, I meant -5. If you plug -1 into there, you get a minimum of g of x is -5. And if you plug the maximum of cosine in there, which is 1, you get a maximum of g of x is 1. So whichever graph varies from 1 to -5 is the g of x curve. And you see that as the curve on the bottom. So g of x is your bottom curve. By process of elimination, h of x is your top curve. So the area of the region is the top minus bottom, or the integral of the top minus bottom over the interval. So you have the integral of 0 to 2 of h of x minus g of x dx. And both these integrals are, or the functions rather, are kind of big. So I opted to split them up into two different integrals and calculate them different or separately by the linearity of an integral. But the scoring guidelines actually doesn't, which I think is weird. But to solve the integral for h of x, you make a u substitution of u equals x minus 1. And in that case, du equals dx. So you don't have to worry about any of the messy constants when you do u substitution. So that integral on the left becomes the integral on the right. And just doing basic integration for polynomials, you get the antiderivative of 6u minus 2/3 u cubed from -1 to 1. So you plug that all in and you get a really disgusting amount of fractions that nobody wants to do, and you get 32/3. Quick side note, it's an exception for this exam, but normally you don't have to actually simplify these arithmetic answers, which I think is really cool, on an FRQ at least. This next integral, so we got the integral of h of x dx, so we want to get the integral of g of x dx. So plugging g of x into this, and making the u substitution, u equals pi over 2 times x, you get dx is equal to 2 over pi du by differentiating both sides and solving for dx, and then you get that integral turning to that integral once you change the bounds as well. And then you get -2 plus 3 cosine u times 2 over pi du. So when you expand this, you get the antiderivative of the integrand before, and the antiderivative is -2u plus 3 sine u. That constant can come out
Can you
front.
guys still hear me?
Yeah, we can hear you.
Okay, cool.
So the antiderivative is -2u plus 3 sine u, and you plug in the bounds. And I noted that sine of pi and sine of 0 are both 0. So when you evaluate that integral, the cosine term actually cancels out completely, which is fantastic because it means less work for you if you recognize that. So that definite integral becomes -4. So we have two values for both those integrals, right? So we can do 32/3 minus -4. That becomes 32/3 plus 4. So that entire area becomes 44/3. And that's the area of region R. The next part asks you to evaluate the volume of the region. It says region R is the base of a solid. For each solid at each x, the cross-section perpendicular to the x-axis has an area a of x equals 1 over x plus 3. Find the volume of the solid. So they were kind of generous here with this question, right? Because normally they don't give you the shape or the equation of the shape. They say it's a square or something like that, and you have to solve for the shape. This case you didn't. So a lot of people really overthought this, saying like x-axis shape of 1 over x plus 3. What shape is that? Because a lot of people with these volume problems, they kind of have a chart in their head of, I have to use this equation to solve for this kind of shape. And in this case, they just straight up gave you it. A good formula to remember is the volume is always the integral of area with respect to x. That's kind of actually the definition of area, but that's a different topic. So you have volume is the integral of 1 over x plus 3 dx from 0 to 2. You can make the u substitution, u equals x plus 3, and the differential change doesn't change, it's du equals dx. So you get 1 over u times du, and then the bounds change from 3 to 5. And then from there, you just integrate. The antiderivative of that is the natural log of the absolute value of u from 3 to 5. And you get a final answer of natural log of 5 minus natural log of 3. And by log properties, it's the natural log of 5 over 3. Now, another interesting thing is that the scoring guidelines didn't actually, make sure you change the bounds when doing u substitution. So the scoring guidelines actually never made that final simplification to natural log of 5 over 3. They just kept it as natural log of 5 minus natural log of 3. So you don't actually have to remember those log properties that you probably forgot from pre-cal. And then, so that's actually the answer for the volume. And it says, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6.
I love those right but do not evaluate questions.
Oh, they're fantastic. So I don't actually think this would be solvable for the AB students. Otherwise, BC you could. You probably hate yourself, but you could do it. So the general volume for these kind of rotated shapes is,
Oh, would that be integration by parts?
yeah. So
LOL.
you do need pi. The volume is pi r squared h. So from there, the volume turns into pi times the integral of the big radius squared minus the small radius squared, integrated with respect to x. So the problem here is identifying what's the big radius and what's the little radius. So we identified g of x as the bottom curve, and it's the radius with respect to the line y equals 6. So when you draw a vertical line from y equals 6 to both curves, you notice the line made with g of x is the bigger one. So that's the bigger radius. So the bigger radius is 6 minus g of x. And furthermore, by the same logic, the smaller radius is 6 minus h of x. So you plug that into the formula for volume, and interesting enough, again, the scoring guidelines don't substitute the definitions for g of x and h of x back in because they're already predefined in the problem. So that's actually a final answer. You don't have to plug in g of x, you don't have to plug in h of x at all, which I think is really neat for time saving purposes.
Okay, if there are no questions, I'm gonna go ahead and get into the scoring guide. Once again, they always give you a point for getting the integral right from the beginning. And so the first part had the most points, it's 4 points. So you set up the integral, you make sure you get the derivative correct. I'm assuming that this was going to be a problem where you couldn't use a calculator, which is why they're giving you points for doing the antiderivative of it correctly. But if you were allowed to use the calculator, then these points wouldn't have been given because you could have stuck the integrand into a calculator and got. For part B, just the integral and the answer. They just want to make sure that you know how to take antiderivatives. And then for the last part, Jacob, do you want to go over it?
Yeah, sure. So I'll go back on the previous slide. So hopefully you're familiar with the whole formula for the volume of a rotated region, right? You have the big radius minus the little radius. And I probably should have used something other than r because r is also the region, but that's just a silly mistake. You probably shouldn't do that. But yeah, so basically you have v equals pi r squared h for the formula of a cylinder, right? And when you split up these cross sections in little cylinders, you get a dh term, meaning an infinitesimal amount of height, and you integrate that over that height to get a volume of an entire shape. There's a lot of good YouTube videos about the intuition behind these formulas for these rotated volumes. But basically, how you functionally use the formula is you have a big R squared minus a little r squared, and you have to figure out what the big R and the little r are. So if you think of it says around the horizontal line y equals 6, right? So that y equals 6 is it's going to brush over that top curve. I'm going to draw it out, actually. That's probably a better idea. Will these size be available after? Actually, how do I post a resource? Yeah, I'm gonna post them in the chat. I'm gonna post the slides in the chat after this is all over. Um, a non-edit permission version. So you have to identify what the big R and the little r are both in terms of the functions. So the big R is just the distance between, or the biggest distance between one of the functions and the horizontal line y equals 6. So when you draw out the horizontal line y equals 6 on that graph, you get a straight line that's tangent to that top curve. So the bigger distance is 6 minus the bottom curve. And we already identified the bottom curve as g of x. And so the bigger distance is 6 minus g of x. That means the smaller distance is 6 minus h of x. Does that make sense? Okay, cool. Sure thing.
Hey.
And we just went over the scoring guidelines as well.
All right, before we get into the last FRQ. Any other questions or things you guys want to cover during this stream? Otherwise, we'll get right into it.
I'm just going to go into it now since we have like 5 minutes left. But if you have a
Cool.
question, just feel free to ask it, and we'll answer it whenever we can.
All right, so this upcoming one covers Unit 2, which I often forget about because that was basically derivatives and like the product rule and stuff. And I always think about like how I used to literally think that was the most difficult thing in the world. But here we are. And then, so that one is quite interesting. Learning how to, when to use it is also great. Oh my God, we got 60 viewers. Hi, everyone. Okay. So what's covered in this next FRQ? Continuity, which is obviously very important, being able to test for continuity. Limits, obviously, which is kind of, it's used in the definition of integrals and stuff like that. So which is why they emphasize in units 1 and 2. Sure you know how to find the asymptotes, and using the squeeze theorem is also very important, which I think it's kind of overlooked. Jacob and I were talking about that earlier. Derivatives, obviously the product quotient rule, chain rule, etc. Knowing how to find common derivatives for like natural law, the x and stuff like that. And then L'Hopital's rule, which can be used for limits when you get indeterminate forms.
All right. So the question starts with functions f, g, and h are twice differentiable functions with g of 2 equals h2 equals 4. They give you an equation of a tangent line to both the graph g and h. So the first thing says find h prime of 2. So tangency at all implies that the derivatives are equal, right? Because when you're going through the process of finding a tangent line, the first thing you do is find the derivative of whatever graph you're finding the tangent line of, and then that tangent line ends up having the slope of whatever that derivative is. So tangency itself implies that the derivative of h is equal to the derivative of the tangent line at 2. So y prime is equal to 2/3 just by differentiating that line. So that implies h prime of 2 is 2/3. And that's surprisingly the entire question. So the next thing it says, let a be a function given by 3x cubed times h of x, write an expression for a prime of x, find a prime of 2. So it's just product rule here. First, you take the derivative of 3x cubed, multiply it by h, and then you take the derivative of h multiplied by 3x cubed, just the product rule. Something you might have forgotten, but hopefully it's recognizable. And then a prime of 2, you're just plugging in 2. You already found, well, you know h of 2 because it gives it to you in the problem, which is 4. You know h prime of 2 because you already had a previous answer for it. And doing all that messy arithmetic gets you 160. So this is a cool one. So the function h satisfies h of x equals that quotient mess. It's known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2 show you worked at least your answers. So L'Hopital's rule means that that quotient ends up having an indeterminate form. So indeterminate forms include 0 over 0, infinity over infinity, 0 over infinity, infinity over 0, 0 to the infinity, 0 to the 0, pretty much anything involving a 0 and an infinity that's a quotient. So we know that the limit as x approaches 2 of the top part, the numerator of h of x, approaches 0 just by definitely plugging in 2. So the bottom should also approach 0 for L'Hopital's rule to make sense. So we have limit as x approaches 2 of 1 minus f of x cubed is also equal to 0. Also gives you that f of x is twice differentiable, which also implies that f of x is continuous. And the definition of something continuous is f of a is equal to the limit as x approaches a of f of x. So we know that f of 2 is equal to the limit as x approaches 2 of f of x. So directly plugging in using limit properties, we have limit as x approaches 2 of 1 minus limit as x approaches 2 of f of x cubed equals 0. So solving for the limit as x approaches 2 of f of x, because you can bring the limit into the power, means limit as x approaches 2 of f of x is equal to 1. However, we established that the limit as x approaches 2 of f of x is also f of 2. So that implies f of 2 equals 1. It is important that you explicitly state why the function is continuous, not just implicitly state by writing out the limit is equal to f of 2, because that's actually in the scoring guidelines. So define f prime of 2. So it also says h of x is twice differentiable, so h of x is continuous, which also means that the limit as x approaches 2 of h of x is equal to h of 2, which they give you in the top as being equal to 4. F of x is twice differentiable, which also means that f prime is continuous, which is also an important thing you need to be explicit about. So when you evaluate this limit, you can evaluate using L'Hopital's rule. You differentiate the top and you differentiate the bottom. When you differentiate, shoot, that should be a squared there instead of a cubed on the f of x there. Whoops. But yeah, you get an f of x squared, negative 3, f prime of x, and just that big mess that you normally do with L'Hopital's, and that all equals 4. However, you know f of 2 equals 1 from a previous part of the problem, so you plug in 1, and then you get f prime of 2 is negative 1/3. So here's the part that really screwed everyone up on that last year's exam. I had friends that really just were like so adamant that like you could not solve this, you didn't have enough information. So the squeeze theorem says if this inequality relation holds and both the left and right side have the same limit, then the middle part of it also has that limit. And you could look up squeeze theorem on Google Images and you'll see why that makes sense. So that means since both of these equal 4, and the reason why both the limits equal 4 is because they're both continuous, which is implied from them being both twice differentiable, which means that that g of 2 and that h of 2 also equal their respective limits as x approaches 2, and they both equal 4. So that means the limit as x approaches 2 of k of x also equals 4 by squeeze theorem. On top of that, g of x is less than or equal to k of x, which is less than or equal to h of x, and you know both g of 2 and h of 2 are 4, as given in the problem. So that means 4 is less than or equal to k of 2, which is less than or equal to 4, which means k of 2 can only be 4, because that is a set of one member. Squeeze theorem on the exam? Probably. So there's a big problem because this is so rarely taught in AP classes because teachers just think it's not going to be on the exam. And it was on the exam last year. Squeeze theorem is not a hard thing to learn. It's one of the easier theorems that you learn in calc. It's very intuitive if you see a graphical representation of it, which is fantastic because graphical intuition is always a good thing.
I'm
So
gonna put a link in the chat that
yeah,
links to like a Khan Academy video and explanation of the squeeze theorem, just in
yeah.
case like you have one of those teachers that just didn't go over it. Yeah.
Taylor polynomial on the exam for this year only for BC. And I don't even know if they're in the on the exam in their entirety, but we're gonna keep on going with this question. So because k of 2 is between 4 and 4, it can only be 4. So k of 2 equals 4. However, because k of 2 is equal to the limit as x approaches 2 of k of x, that by definition means k of x is continuous. So that's the final answer for part G.
Okay, so obviously the first part when Jacob went over it, it was just a simple answer. And then for the second part, make sure you know all of your derivative rules. And this is just pretty simple. It was just the product rule. And then part C had the most amount of points. And I'm gonna look at it a bit more clearly from here. Part C, getting the limit correct in order to find f of 2, and then making sure that you know when to apply L'Hopital's rule. So whenever you're using a limit and it just you get any of those indeterminate forms, you should right away think to take the derivative of the numerator and the denominator. And then you're going to use that to find f prime of 2, which is going to be your last point. And then part D, surprisingly, is only 1 point because the whole process is just kind of showing that you know how to show that this function is continuous.
I'm trying to find the topic list
I'm
for
pretty sure Taylor's are on the.
yeah, but someone in the chat asked about Rolle's theorem, and I'm almost positive that would, but I don't want to say something without knowing it. Because I can't imagine that being cut off on the exam since that's just like a basic part of applications of derivatives. So I'd bank on yes, but you can dig up a PDF or something like that a little bit, just to see what's happening. Because, yeah, I mean, I can't find it right now, but I'm sure if you did some searching, you could find a full topic list. Okay, roll summaries. I didn't know that. That's cool. Okay. So before we end the stream, we could take some more questions. We're already a little bit over time on our time slot, but that's okay. Just anyone ask any questions they want to. And we're also hosting cram sessions next week for this class. Unfortunately,
Yes.
you do have to pay for them. They are actually full 5 hours. Students are doing 2.5 hours, which is a lot of time. It's a 5-hour review. So if you really are stressed through the exam and you have the money for it, I highly recommend it. This software or this program has actually personally saved me from a lot of stuff.
Best ways to study. I mean, I used to ask my math teachers this all the time, in like freshman year and sophomore year. Do as many problems as you can and try to focus on the stuff that you think that you're going to be weak in. So, for example, like, I mean, for Unit 8, I love Unit 8, so I might only do 1 or 2 free responses for that unit. But if I struggle with like series and sequences, then I might take extra time to find like a variety of free responses. And College Board currently has released a lot of sources that you can use because they understand that like not everybody's going to have opportunities to have online classes and stuff. So using a lot of their resources on College Board Classroom, and yeah, just constantly working problems. There really is no better way to learn math. I mean, you can look through your notes, but the best way to learn and to study math is to work through problems.
I agree with that.
Yeah, errors with trapezoid ruler alternating series error. Alternating series will not. Lagrange error bound is not going to be on the exam. It was one of the ones they took out for this year. It normally would have been on BC, but it's not going. It's not going to be on the exam this year.
The cram session is on Monday, which is just us pretty much going over the entire course in 5 hours. Or rather,
Yeah.
we're
Me
actually
and Jacob take up the first 2.5 hours, and then a calculus teacher will take the second half.
yeah. So it's a lot of time. It's a lot of time you could be spending studying, especially since it's the day before the exam. But yeah, is there more?
We're going to be going through the content and then answering questions that are in the chat. So mostly we're always going to make sure that our sessions are geared toward you guys and your questions. So we're always going to try to answer your questions in the chat and go here. And then we're just going to be going through like unit content for 2.5 hours.
Yeah, that's gonna be I'm gonna need probably a coffee for that one.
Yes, me too. But we hope you guys can make it, and thank you very, very much for attending this stream. And we hope that we helped you guys at least a little bit, and you guys are going to ace this exam. It's two questions, and we just really hope that we were able to help you guys with calculus.
I'm gonna put the link to the slides, and let me see if anyone with the link can view it. Cool. So the link to the slides is in the chat. If you want to, I should probably close this so no one gets doxxed. So yeah, you can go there, look at the slides. If you have any questions and you just want to DM me on Instagram, my Instagram is in the chat. Feel free to DM me. I do this every stream. I've gotten like 2 DMs maybe in a stream for 9 months. But yeah, I mean, if you have a last minute question, feel free to DM me, and I'm cool with it. I'm not gonna press her lean to put her Instagram in the chat either, because that's kind of weird. But yeah.
Hold on, I'll pause.
Just leaving that there for you guys. Oh, cool.
I'm like nocturnal basically, so if you have any like last minute 3 a.m. questions, I'll answer those too.
All right. Thank you for attending, and good luck with your studying, guys. Bye.